I first saw this problem in a book by Yakov Perelman. The name of the book was Mathematics Can Be Fun. And then I saw it in some other texts as well. It is a very simple looking problem, but it has deep connections with number bases. Uh, Hello everyone and welcome to Excursion in Mathematical Olympiads series at Chinta's YouTube channel. If you want to see the upcoming episodes of this series, feel free to subscribe to our channel. My name is Ashwini Dashgupta. I'm a faculty member at Chinta. You can check out chinta.com in the link in the description. We offer outstanding mathematics programs, mathematical Olympiads, ISI and CMI entrance programs, research projects for school and college students. So feel free to check them out. Now, on to the problem. So, it says that you want to measure the weights from 1 to 40, all the integer weights. You have a standard weighing pan. So there are two pans. You put weight in one or both of the pans, and then you put what you want to measure in one of the pans and you try to measure it. It's a very standard tool. And you are allowed to choose 4 weights. You are allowed to choose 4 weights only and measure all of these distinct 40 different weights. So, what are those 4 weights? I'll give you something that is not an answer so that you can understand what is going on. Let's suppose we have 4 weights which are 1, 2, 4 and 8. Suppose these are the 4 weights. Let's see what can we measure using these 4 weights. Of course, we can measure 1, we can measure 1 plus 2, we can measure 2 itself. In fact, we can measure 2 in 2 different ways. You can put 2 in this pan and then measure a weight of 2. Of course, you can do that. Or you could do something like this. You could put 4 in this pan and 2 here. Now you can measure 2 again, but because this is 4, this is 2, so it's basically to bring it to balance, you have to put another 2 here. Thereby you are able to measure a weight of 2. So you can write 2 as either just 2 or you could write it as 4 minus 2. So that's what's going on. Now, then you can measure 3, then you can measure 4, then you can measure 5 because 5 is 4 plus 1. Then you can measure 6 because 6 is 4 plus 2. You can measure 7 because 7 is 4 plus 2 plus 1. And then you can measure 8 because 8 is 8. So now you can also measure 8 plus 1 which is 9, 8 plus 2 which is 10, 8 plus 1 plus 2 which is 11, 8 plus 4 which is 12, 8 plus 4 plus 1 which is 13, 8 plus 4 plus 2 which is 14, and 8 plus 4 plus 2 plus 1 which is 15, and that's the most you can measure. So if you had only these 4 weights, you could measure up to 15, 1 to 15, all of these numbers. Now, why could you do that? Why could you do that? That's where the mathematics says maybe you can simply guess what these 4 weights are now if you want to measure from 1 to 40. But what we are really interested in, because it's an excursion in mathematics, not excursion in guesswork. So the reason this works, as I said, has deep connections with number bases, because 15 is 1 times 2 to the power 0, which is basically 1 times 1. So you had a weight of 1. Then 1 times 2 to the power 1. Then 1 times 2 square. then 1 times 2 cube. So in binary system, you have 15 equals to 1111. That's what's going on. So in binary system, you cannot measure from 1 to 40. You can measure only 1 to 15 using these four tools. So again, think about what four weights you will need for numbers from 1 to 40. But as in most classes at Chinta, we try to say this, that when you see the problem, you then try to think what is the underlying concept. So whatever number base you are in, you are allowed to use plus or minus. That's something important, because as you remember, we could have gotten 2 using 4 minus 2. We did not need to use plus all the time. So you are allowed to use plus or minus, and you are allowed to use only one of the weights, or one of each kind of weights, of weight. So you either use that or you don't use that. So it's basically either 1 times the value of the weight, or you have 0 times the value of the weight, or you could have, since you can subtract, you could have minus 1 times the value of the weight. So suppose these four weights, now by this time I think many of you have guessed what the four weights are, but if you have not, that's fine. I mean, if you have or if you have not, let's do that in this manner. So if the four weights are A, B, C, D, and you are only allowed to use 1, 0 or minus 1 as the coefficient, that is, you either take it or you don't take it or you subtract it. These are the three possibilities that what you can do with the weights. So you have one, so this is a constant times A, k1 times A plus k2 times B plus k3 times C plus k4 times D, where k1, k2, k3 and k4 are either belongs to 0, 1 and negative 1. So you can put a 0 here, or you could put a 1 here, or you could put a negative 1 here. So now the question is, if the ki's k1, k2, k3, k4 are allowed to be 0, 1 and negative 1, and A, B, C, D are the four chosen values of the weights, you want all of these combinations to give you numbers from 1 to 40. So that's the question I want you to answer. I will put the answer in the comment, of course, so that you can check whether your answer is right or not, and whether you can go up to 40, or maybe you have to stop at 39. You have to check. Maybe you can go a little bit more than 40, so you have to think about that. If you can tell me what is the connection of this problem with number bases, that would be great. Write it in the comment. And I will also add a link to a toolbox for mathematical Olympiads in the description. So do check that out. It's a free toolbox that we give out, that we share with all our students and people who are also not our students. So keep on doing great mathematics. Please subscribe if you want to see the next episode of this particular series, Excursion in Mathematical Olympiads.